Guys, welcome back to Tronic Synergy, where we do fun stuff all day, all time. And today we have done another circuit. It's a full subtractor circuit. Last video I did a half subtractor circuit. So this full subtractor circuit is just a continuation of the half subtractor circuit. It's just a combination of the two half subtractor circuits to get a 3 input full subtractor circuit, and it has outputs of difference and borrow out. So the input that I've added is a borrow in input. This was not there initially. Initially we just had A and B, so now I've added a borrow in, and then the outputs are still the same, difference and borrow out. So my circuit is right here, you can check. We have simplified switches. So last time I did we did the connections using an NE555 in bistable mode as the switches, but this time around I got a dip switch, which is much better. It has eased the connection. So I have a dip switch here to show you how a dip switch looks like. So this is a dip switch. The dip switch, it has 4 switches, so this is much better than having a lot of NE5s in the breadboard and are just doing simple on and off. So it's a dip switch, and it switches are very small, but we're going just to use them like that. This has 4 switches, but I'm only going to use 3 switches because we have 3 inputs in our circuit. So my circuit is right here, and it should be doing the operation as this truth table right here. So it's on already and all inputs are 0. So we are going to start off. So when all inputs are 0, we get a 0 difference and a 0 borrow out. Then the next one, if borrow in is 1, then we should get a 1 output and a 1 borrow. So we put switch 3 on. Once it's on, we get a 1 output and a 1 borrow out. Then the next one, when B is on and all the others are off, so we put borrow in off. Borrow in off. Then we put B on B. So these are A, B, and borrow in. So B is on. So once B is on, we should get 1 output and a 1 borrow out. Then the next one, when B and borrow in are on, so we're just going to put on switch 3. So when B and borrow in are on, we get a 0 output and a 1 borrow out, like that. Then the next one, when A is on only, so we put B and borrow in off, then we put on A. When A is on, we get 1 output and a 0 borrow out, like that. Then the next one, when A and borrow in are on, so put in borrow in. So when A and borrow in are on, we get a 0 output and a 0 borrow out. Then when A and B are on, we get a 0 output and a 0 borrow out. And the last one, when all inputs are on, we get a 1 output and a 1 borrow out. So we put all inputs on, we get a 1 output and a 1 borrow out, and that's what we are going to do today. Enjoy. So welcome back, guys. So today we are going to do a full subtractor circuit. It's much more powerful than the half subtractor circuit because this one you have 3 inputs, so you can do the subtraction of 3 binary digits, and you get an output of difference and the borrow out. So it's pretty simple. That's the circuit. So these are the input sections where we are going to connect our input. So this is the input A, this is the input B, and this is the borrow in input. So they have LEDs. I'm using blue LEDs right there just to show you which input is on, and they are being protected by 1 kilo ohm resistors. And our our deep switch right here, it has being connected to ground using 5.6k kilo ohm resistors. Then our inputs are being taken from, so this is A going to the first input of the XOR gate, and then B, which is right here, then B being taken by the second as the second input of the XOR gate, and then borrow in taken as the third input of the second XOR gate. So from here, A and B in the first XOR gate, the output enters the second XOR gate, and then the input of the second XOR gate is taken from the third switch. The third switch is the borrow in. Then the output of that gives you the difference of those three binary digits. So this gives you the difference between these three binary digits. Then to get the borrow out, we take input from the first XOR gate input A being passed through a NOT gate into an AND gate. Then the other pin of the AND gate is taken from B directly. The output of that AND gate is going straight to an OR gate. Then the second XOR gate, same connection to the first AND gate. So we take first input of that XOR gate to a NOT gate, then to an AND gate. Then the other input of that AND gate is taken from the borrow in, which is the third switch of our deep switch. So the output of that AND gate is taken to this OR gate, which gives you the borrow out. So the output of this difference, I've taken it and lit green LED to show you the difference. Then the borrow out is lighting up a orange LED or a yellow LED to show you the borrow out signal. So this is our truth table, and our circuit should perform the same way as this truth table right there. So you can pause the video, you can take a screenshot, or you can just look at it very nicely, and we can build it together. So I have my circuit already right here. This is my circuit. It looks pretty much complicated, but it's not complicated, just easy connections. Only that I don't have an XOR gate, so I'm building an XOR gate directly using OR gates, AND gates, and the NOT gate. I don't have an XOR gate integrated circuit, but next time I'm going to have it, and it will be looking much simpler. So my deep switch is right here, which is much better than having any 555s working as a switch in bistable mode. It really eases off the space of the breadboard. Then our LEDs are right here. So this first LED is going to be A, second LED will be B, the third LED will be borrow in. Then yes, so the other integrated circuits are AND gates, OR gates, and the NOT gate. So this is an AND gate. It's a D74HC008. OR gates, it's a SN7432, and this also an AND gate is a SN7408, and the last here is a NOT gate, which is a 7404. Yes, 7404. And yes, so those, I'm using a 774 series logic gates right there. So my power supply, as I said, is a 5-volt power supply. You can use any from 3 to 9 volts, but make sure you check the ratings of the integrated circuits to make sure that you don't damage them. So I'm going to start. I've powered it on, and yes, I powered it on and all my inputs were on. So I'm going to put all the inputs off so that we start when all inputs are 0. So I'm going to put them on, off, all of them, then we are going to start. So when all inputs are off, as they are right now, we get a 0 difference and a 0 borrow out. 0 difference and a 0 borrow out. Then when borrow in is on, we get a 1 difference and a 1 borrow out. So we put on borrow in, pretty small switches, so I'm using a screwdriver. So when 3 is on, or when my borrow in is on, we get a 1 difference and a 1 borrow out, like that. Then the next one, when B is on only, so we put off borrow in, then we put on B, we get a 1 output and a 1 borrow out. 1 output, 1 borrow out. Yes, so when B, now we go to the next one, when B is on and borrow in is on, so we put on borrow in. So when B is on and borrow in is on, we get a 0 output, 0 difference and a 1 borrow out. 0 difference, 1 borrow out, like that. Then we go to the next one, when A is on and B and borrow in are off. So when A is on only, so we put on A. When A is on only, we get a 1 output and a 0 borrow out. 1 output, green LED, 0 borrow out, or orange LED is off. Then the next one, when A and borrow in are on, so I'm just going to put on borrow in. When A and borrow in are on, like that, we get a 0 output and a 0 borrow out. 0 output, 0 borrow out. Then the next one, when A is on and B is on but borrow in is off, so we put off borrow in and we put on B. So when A and B are on, we get a 0 output and a 0 borrow out, like that. Then when all inputs are on, we get a 1 output and a 1 borrow out. I'm going to put them on. Then when all inputs are on, we get a 1 output and a 1 borrow out. And that's basically how a half subtractor circuits work. So you can rewind the video and you can check the connections wisely. It took me time before building this because I was doing some mistakes with these jumpers, because I'm connecting, because making an XOR gates requires 3 logic gates for you to make. So please make sure that you take some time and make them just slowly, so that you don't do mistakes like I did. So there you have it. That's a full subtractor circuit, and next time we are going to be looking on how we can start making an ALU or the memory using logic gates. So thank you very much guys for watching. Please subscribe to Tronics Energy, where we do fun stuff all day, all time. Bye.